Thank you very much for attending this session. Today's talk is about the news vendor problem or the newsboy problem. And it was and is using this topic when we define the optimal service level. I used to teach this material with mathematical proof. Gradually, I realized that we do not benefit at the level that I expected when I go through the proof. Therefore, for a couple of years, I just passed the formula to the students. But it is a couple of years I have found a way that we cannot say it is mathematical proof, and it is not just giving the formula to a student without knowing anything about what is happening in the background. Therefore, today I find a way to do not prove it mathematically, but prove it somehow using common sense of how to define the optimal service level. Up to now, we have said optimal service level is 95%, 90%, 85%. Now we want to explain what is behind these percentages, how they are defined. So our topic is the news vendor problem. And this is a very important topic because, as you see here, there is even a book on this problem, Handbook of the News Vendor Problems. Like usual, before going into the problem, I want to emphasize that it is very important that you form teams with your classmates and not only communicate with your teammates, but also have intra-team communications. That is the best way of learning, and that is what you can practice it in the next 80 years of your working life. And in my course, after you form teams, you take it to the other courses and take it to future semesters too. Let me go back to the discussion that we had on what is operations management. What are the objectives of operations management? Operations management tries to create a smooth flow. Operations management tries to understand trade-offs. Operations management tries to remove variabilities. Operations management tries to align process competencies with product attributes and customer value proposition. And operations management tries to optimally locate product buffers, capacity buffers. Product buffer means we put some inventory somewhere. Capacity buffer means we have additional capacity. For example, Zara has about 50% additional capacity because they want to be able to quickly put a product on the shelves as soon as they feel that the market likes a specific product. And time buffer means customer wait. For example, if I go to Walmart, and if I'm looking for something which I'm not going to spend too much money on it, if it is not there, I may wait. And examples of these are inside our game. For example, you order raw material, you order kits to create product buffer. You will retain extra capacity to avoid going to close to 100% capacity and have a long waiting line. And you follow time buffers because when you do not have enough capacity to deliver lucrative orders in a short period of time, you go for less lucrative orders for more time. Also, let me refer to two simple multiple choice examples. The first one is, why do we develop inventory models, at least very basic inventory models. The objective of EOQ is to minimize total inventory cost. And the objective of ROP models that we discussed is to minimize the likelihood of stockout. So B here is the correct answer. Here we have demand for a product. We have daily demand, average is 20. Standard deviation is 4. Lead time is 4 days. We know that demand during lead time demand equal to 4 days multiplied by demand per day. That is the average of the demand during lead time, which is 80. And standard deviation of lead time demand is equal to square root of the lead time, which is 4, multiplied by standard deviation of daily demand, which is 4. Square root of 4 is 2, multiplied by 4 is 8. Therefore, if this is the daily demand, then demand during lead time, instead of 20, I will have 80. And instead of 4, I will have 8. And now we want to identify a point such that the probability of demand being less than this amount is 100 minus 1%, which is 99%. And the probability of being greater than that amount is 1%. So we are looking for a normal variable, which the probability to the right of it is 1%, probability to the left of it is 99%. And that is easy to do. Equal to norm inverse, norm inverse. And then it asks us what is probability. Probability to the left 99%, average 80, standard deviation 8 is 98.61. Usually we round up this, equal to round up. If I round up this to 0 decimal point, I have 99. Now I can find it out what is my service level or what is my risk. This was 0.99. If I round it up, what is my service level? Here I again go over there, but in this time norm distribution, not norm inverse, norm distribution. What is my X? 99. What is my average? 80. What is my standard deviation? 8. And because I am looking for probability and I am not looking for the height of the curve, I enter 1. Now my service level is a little bit more than 99%, it is 99.12. Now I start a problem. We have a product. The demand for that product in a specific period has normal distribution with average of 100 and a standard deviation of 25. Suppose price of the product is 80 per unit and purchase price is 40. So I buy a product for $40. I sell it for $80. And the difference is 40. I make $40 profit. That is what we call it underage cost. That means if I don't have the product, then I have lost that much profit. However, if I have the product, if I have bought the product and I have not sold it, then I can return it for $20. I have bought something for $40, I returning for $20, I lose $20. For a minute, suppose this is 0. So if I don't sell it, I have lost $40. just to start the discussion. Underage cost, if the demand is there but the product is not there, we compute it, it's $40. So $40 tells me have larger inventory, because if you don't have enough inventory for each unit of demand, if you cannot satisfy it, you have lost $40. On the other hand, overage cost, if it was 40, I said, let's for a minute, suppose it is 40. Suppose if we cannot sell the product, we cannot return it, and that's lost. Therefore, underage cost continually tell me order less, because each unit that you have, if you cannot sell it, you will lose $40. So there are two powers. One is trying to tell me order more and more, have more inventory. One is trying to tell me have less inventory, and they are equal. Therefore, they keep me in middle. I will order average of what is needed. And average what is needed here is 100 units. This one takes me to this way, this one takes me to this way, because they are equal, they stay in the middle, and therefore the share of this one which tries to take me to the right hand side is the blue area divided by summation of blue and red area, and that is 50%. And in that case, my service level is 50%. Underage cost in our example was $40. Overage cost was $20, because if I cannot sell it, I can return it for $20. Therefore, overage cost, if the product is there and demand is not there, it's $20. So $40 is trying to tell me have more inventory. $20 is trying to tell me have less inventory. Power of this 40 compared to the total power is CU, underage cost, divided by CU plus CO, divided by underage cost plus overage cost. And therefore, this 40 will take me more to the right. How much more to the right? Such that this ratio of blue to the total ratio is equal to 40 divided by summation of the two service level. 40 divided by 40 plus 20, that is 0.67. Now let me explain how much do we order. Let me open my Excel sheet. Equal to 40 divided by 40 plus 20. That is the service level. That is how much area to the left I should have. Therefore, equal to norm inverse probability this much. Average was 100. Standard deviation was 25. Therefore, we ordered this much. And in that case, we have 0.6666 service level. But suppose round up this one and 0. When in that case, norm distribution 100, 25, and 1, because you are going to compute probability, a little bit more than 67. This is a little bit less than 67. So as a matter of fact, this was the whole solution to this problem. This probability is 66.67. We go to Excel and we compute. Now let's go to problem 2. So here we buy the product for 1800. we can sell it for 2,500. CU is equal to 2,500 minus 1,800, and that is 700. CO equal to, we purchase for 1,800, and if we cannot sell it, we return it. Therefore, overage cost is 100. We have everything to solve this problem. We know that the demand has mean of 150 and a standard deviation of 15. 700 underage cost, 100 overage cost, service level, CU divided by CU plus CO. It's a normal distribution. We want this probability to the left to be 0.875 and to the right is 1 minus that. And if you go to normal function in Excel, you get 167 point something. You can round it up to 1. We place an order for 168, which is 18 units higher than average. That is 18 units when underage cost was able to push us to the right, and we refer to it as safety stock. Now we have this new problem. Sales price 30, purchase cost 10, salvage value. I mean, if we don't sell the product, we can give it to someone for $6 or return it to the seller for $6. Our sales and marketing department, they believe that each time that a customer comes for our product, if we don't have that product, in long term, it will cost us $1 per product. So that is another cost that we have if the demand is there, but the product is not there. Demand for a product is normally distributed. Demand for a product is normally distributed. Average is 4,000. Standard deviation is 1,000. A distribution like this. Now we want to identify where is the service level such that with a small probability we cannot satisfy the demand, and with other probability we can satisfy. We want to know how we can find this point. That is based on underage cost and overage cost. Overage cost, the product is there, but the demand is not there. We have bought the product for $10. We need to return it for $6. Overage cost is 10 minus 6, which is equal to 4. That is the cost if the product is there, but the demand is not there. However, here, if the demand is there, but the product is not there, demand is there, but the product is not there. First, we have not made this profit, that is $30 minus 10, which is equal to 20. We have not made it. But also in future, for every customer, every product, we have damaged our image by $1. Underage cost is not only 20, it is 20 plus 1. Demand is normally distributed. Overage cost, if we have the product, but the demand is not there, we have bought it for $10, we sell it for $6, we lose $4. Underage cost, we lose the profit that we could have made, plus the damage to our reputation, 21. Now the rest is straightforward. This is service level 0.84, 20 divided by 25. Then we go to normal distribution. We use this function. We have the probability, we have average, we have standard deviation. We get, and if we round it up, service level would be a little bit more than 84%. Now let's look into this situation. Very similar with a little bit difference. So we sell the product for $100 and buy it for $60. Therefore, if we sell it 100 minus 60, it will be equal to 40, which is, but what is CO? We have bought it for $60. If we don't sell it, not only no one will purchase it from us, but we need to spend $10 to dispose it. So it's 60 plus 10 equal to 7. And that is overage cost. We have underage cost, we have overage cost, everything is clear. The only difference is we have daily demand. We don't have demand during lead time. Daily demand for your product has normal distribution, average 20, and standard deviation 5. That is demand per day. Sales price 100 per unit. You have decided to close this business in 60 days. Your supplier has decided to close his line immediately, but has agreed to provide your last order at the cost of $60 per unit. Any unsold product will be disposed at the cost of $10 per unit due to EPA regulations. How many units do you order? So we have daily demand, but we will need to compute demand during 60 days. And that is quite straightforward. 60 multiplied by 20. That is these two numbers which are multiplied by each other. It make it 1200. And then square root of 60 multiplied by 5. And that is a standard deviation. So this is lead time demand. And this is standard deviation of lead time demand. And you have the overage cost 40 and underage cost 70. That's it. If you order this much, that is 50% probability that demand is more than what we have, 50% probability that demand is less than what we have. CU is equal 40, CO 70, service level is 40 divided by summation of 40 and 70, and it's even less than 50% because overage cost is high. Of daily demand, square root of lead time, and then we'll get this value, and then go to normal distribution as usual. Use norm inverse, that is 40 divided by 110. This is average demand during lead time. This is standard deviation of demand during lead time. That is how much do we need to order. I would like to stop this lecture here and go back to the problems. I think you should be fine. Thank you for your attention, and I will see you in my next lecture.